Hey mate, did you understand our teacher's lesson for today?
Which one?
Actually, it's about the chemical reaction and chemical balancing.
Aha! That's quite interesting, isn't it?
Oh, yeah, quite tricky. Hey, you.
Hey, I wonder if you could join me at the canteen. I just want to grab some snacks and study. My treat.
Yeah, sure.
What's up, nerdy?
The chemistry lesson is a bit difficult for me, but I can understand it too.
Mind if I join you guys? Got something to spill.
Oops, they're gonna study. I have some snacks here and some books that may help. How's that?
Sounds great to me. So, let's go.
On previous grade levels, we have learned that substances undergo chemical bonding that results in breaking of bonds and formation of new bonds. In this way, new substances are formed. In this example, the reactants hydrogen and oxygen reacted from one another to form new substances which are molecules of water. Formation of new substances means a chemical reaction has taken place.
We also have learned about chemical reaction. We've gained understanding that it is a process in which one or more substances, the reactants, are converted to one or more different substances. The products, substances, are either chemical elements or compounds.
Agree. A chemical reaction rearranges the constituent atoms of the reactants to create different substances as products. Chemical reactions must be distinguished from physical changes. Physical changes include changes of shape, size, and state, such as ice melting to water and water evaporating to vapor. If a physical change occurs, the physical properties of a substance will change, but its chemical identity will remain the same.
Now, what are these reactants and products that are included in chemical reactions? Keep in mind that the chemical reactions occur when chemical bonds between atoms are formed or broken. Substances that go into a chemical reaction are called the reactants, and the substances produced at the end of the reaction are known as the product. For example, when magnesium reacts to oxygen, it forms magnesium oxide. Magnesium and oxygen gas are reactants, while the magnesium oxide is the product.
To better understand the topic, let us identify the reactant and products in the following examples of chemical reactions. Example number 1. Liquid hydrogen peroxide in the presence of the catalyst manganese dioxide produces water and oxygen gas. Here, the reactant is hydrogen peroxide. Manganese dioxide is not a reactant but rather a catalyst. The products are water and oxygen. Example number 2. Iron reacts with aqueous copper sulfate and forms iron 2, sulfate and copper. The reactants are iron and copper sulfate, while the products are iron 2, sulfate and copper.
The reactants and products in a chemical reaction can be written in a chemical equation. These are the common symbols used in writing chemical equations. The plus sign indicates a combination of the reactants or products. An arrow means to yield or to produce. Two arrows in opposite direction meaning it is a reversible reaction. If a delta symbol is placed above an arrow, it indicates the heat is supplied to the reaction. If a formula is written above or below the yield sign, it means a catalyst or solvent was used in the reaction. And symbols written beside reactants and products, S, L, G, and AQ means S for solid, L for liquid, G for gas, AQ for aqueous, meaning the substance dissolved in water.
Let us use the examples earlier to write the chemical reactions and chemical equations. Using the formula and symbols, here are the chemical equations of the two chemical reactions. In equation number 1, notice how the equation is written. We use the formula of liquid hydrogen peroxide, catalyst manganese dioxide, water, and oxygen gas. The reactant H2O2 is written first. Since the manganese dioxide is a catalyst, not a reactant, its formula MnO2 is written above the yield sign and followed by the products produced by the reaction. A water H2O plus an oxygen gas O2, symbols written beside the reactants, and products indicate what type of matter they are. For the chemical equation in the second chemical reaction, the reactant iron, a solid, is combined with another reactant, aqueous copper sulfate, and aqueous and produce the products iron sulfate plus a copper.
Let's study the types of chemical reactions. We have combination reaction, decomposition reaction, single displacement, double displacement, and combustion reaction. Combination reaction, or also known as the synthesis reaction, it is a reaction in which two or more substances combine to form a single new substance. Below is the general form of a combination reaction. An example is when magnesium combines with oxygen gas with the presence of heat to produce powdered magnesium oxide. Next is decomposition reaction, a reaction in which a compound breaks down into two or more simpler substances. Below is the general form of a decomposition reaction. An example is when hydrogen peroxide with the presence of catalyst manganese dioxide produces water and oxygen gas.
Next is the single displacement reaction, a reaction in which one element replaces a similar element in a compound. Below is the general form of this reaction. In this reaction, if element C is a metal and replaces element B, which is also metal in the compound. When the element that is doing the replacing is a non-metal, it must replace another non-metal in a compound. For example, iron reacts with aqueous copper sulfate and forms iron sulfate and copper. In this reaction, iron is a highly reactive metal replacing copper and forming iron sulfate and copper. Next is double displacement reaction, in which the positive and negative ions of two ionic compounds exchange places to form two new compounds. Below is the general form of this reaction. This reaction generally occurs between substances in aqueous solution. In order for a reaction to occur, one of the products is usually a solid precipitate, a gas, or a molecular compound like water. For example, an aqueous copper sulfate reacts with aqueous sodium hydroxide to produce insoluble copper hydroxide and sodium sulfate solution.
The last type of chemical reaction is combustion reaction. In this reaction, a substance containing hydrocarbons reacts with oxygen gas, releasing energy in the form of light and heat, and producing carbon dioxide and water.
If you have noticed, during a chemical reaction, the mass of the reactants is equal to the mass of products. This is because all chemical reactions follow the law of conservation of mass. Antoine Lavoisier, a French chemist, proposed the law of conservation of mass, which states the mass is neither created nor destroyed in chemical reactions. This means that during the chemical reaction, the atoms are only rearranged and the mass of the reactants is conserved in the products.
Every chemical equation adheres to the law of conservation of mass, which states that matter cannot be created or destroyed. Therefore, there must be the same number of atoms of each element on each side of a chemical equation. In essence, the number of atoms of all elements in each side of a chemical equation should be the same. If they're not, you need to work on providing integer numbers preceding in each reactant or product. These numbers are called coefficients. They represent the whole number ratio of a number of molecules or atoms involved in the reaction.
Since we have tackled the gist of chemical balancing, let's now proceed with steps. First, we need to write the chemical equation of the given chemical reaction. For example, aluminum reacts with oxygen to produce aluminum oxide.
Now that we've written the equation, let's now move forward to the next step.
We need to make a list of all the elements on each side under the equation for both the reactants and product.
Third step, Identify the number of atoms in each element. In our example, as we can see, on the reactant side, we have an atom of aluminum and 2 oxygen atoms. On the side of products, we have 2 aluminum atoms and 3 oxygen atoms.
As we can observe, the number of atoms on the reactants and products are not equal. This is where balancing occurs. Fourth step, find the lowest possible coefficients to balance each atom.
For the reactants on the aluminum, we can multiply it to 4, and oxygen we can multiply to 3, having a total of 4 aluminum atoms and 6 oxygen atoms.
Now, on the product side, for the aluminum, we can multiply it to 2 to equate to 4. For oxygen, we can multiply to 2 as well to equate with 6 on the other side.
Now we can observe the both sides have the same number of atoms on each element.
For the products, we can place 2 on the left side of the aluminum as the coefficient and 2 on the oxygen. Now, we have this balanced chemical equation.
Also note that in balancing chemical equation, we cannot change subscripts, only the coefficient, and it should always be a whole number.
Now, let's have another example. Ethanol can be used as a fuel, source in an alcohol lamp. Write the balance equation for the combustion of ethanol.
Now let's write the chemical equation of the given chemical reaction.
Now let's enumerate the given elements and their atoms.
As we can see, they are not balanced. The number of atoms in each element in reactants are not the same with the number of atoms of the product.
Now, we need to determine the lowest possible coefficients to balance each atom.
Here we can multiply the number of atoms of the product to equate with the number of atoms of the reactant. So we multiply 2 on the carbon and 3 on the hydrogen.
Though carbon and oxygen are balanced, we are left with unbalanced oxygen. Since we have placed coefficients 2 and 3, the number of oxygen was also changed. Thus, we need to add a coefficient on the reactant side to make it equal to the product side. So, let's place a coefficient on the oxygen. Let's place 3 on the oxygen.
Yay! Now we have a balanced chemical reaction.
Hooray!
Let's put in mind that the total mass of reactants are always equal with the mass of products. This is provisioned and clearly stated on the law of conservation of mass, that no atoms shall be created nor destroyed during chemical reactions. However, they will undergo rearrangement.
How fascinating, isn't it?
Yeah, I love how change becomes beneficial and caution to our environment. It is also present in chemical reactions.
Ay, it's been a long day, everyone.
Yeah, I agree. Long yet productive day. Thanks guys, love it.
Thank you for the snacks and ideas, guys!
Let's do this more often.
I agree. We may not know if we'll part ways on senior high. So, yeah. Thank you, guys.
Senior high is coming up. Let's cherish these precious and worth-keeping moments.